On homework packet 4, numbers 11 through 15 are all going to be solved using tree diagrams, so I'm going to go through an example here to help you get started. 12 might be the most complicated one, so I'll work through that. We have 3 jars, jar A, jar B, and jar C, so we'll start by drawing those. You start off by choosing a jar, so you're either going to pick A, B, or C. Each jar is filled with white and black balls, so we'll add that to the tree diagram. So after you choose a jar, then you're going to select a ball. So it's either going to be white or black. No matter which jar you pick, it's either going to be white or black. So now let's fill in the probabilities, starting with choosing a jar. Jar A is bedazzled, so it's got a probability of 1/2. People are more likely to pick it. And jars B and C are then equally likely to be picked. So A has a 1/2 chance, and then the remaining 1/2 is split in between B and C evenly. So they'd be a 1/4 chance apiece. And for this problem, it's easier to leave them as fractions because you'll see it coming up. Some of the decimals here would be repeating forever, and you'd have to round if you wanted to write it as a decimal, but you can keep it accurate as a fraction. So we'll want to leave everything as fractions to keep that accuracy. So 1/2, 1/4, 1/4. Now looking at choosing the balls, so from jar A there's 1 white and 1 black, so there's 2 balls in there. You're equally likely to choose either one, so there's a 1/2 chance you get a white ball and a 1/2 chance you get a black ball. So add that to the tree diagram. After you choose A, you have a 1/2 chance of picking a white and a 1/2 chance of picking a black. Jar B has 3 balls, 2 whites and 1 black, so there's going to be a 2 out of 3 chance of getting a white and then a 1 out of 3 chance of getting a black. So here it is. After choosing B, you have a 2/3 chance of getting a white, 1/3 chance of getting a black. And this decimal would be the 0.66666 repeating forever, and this would be 0.333 repeating forever. So this is a reason you want to leave it as fractions, because you don't want to have to round those decimals, because rounding will throw off your answer. And jar C is going to have decimals too, so another reason to leave it as fractions. There's 3 balls there, 1 white and 2 black. So add that on a 1/3 chance of picking a white and a 2/3 chance of picking a black. And so now figure out the probability of each branch all the way to the end. So the chances of picking A and then picking a white marble would be 1/2 times 1/2, which is a 1/4. So do that for all the branches. So here they all are. I've actually, like this one's 1/4, I actually changed it to 3 out of 12. I gave them all the same denominator so that if I have to add any of these fractions together, it'll be quick and easy because they all have the same denominator already. And you should check all your probabilities of all the different branches should add up to 1. So 3 plus 3 is 6, 8, 9, 10, 11, 12. I have a total of 12 twelfths, which is equal to 1. So it did all the multiplication correctly. So part A says find the probability that the ball is drawn from jar B given that it is black. So out of all 6 of these possibilities, there's 3 of them that end in you selecting a black marble. And we're given that we have a black marble, so we have to have gone along one of these 3 paths to end up with a black marble. And so we have a total of 6 out of the 12 occurrences that end in a black. So getting a black marble occurs 6/12 of the time. Put that on the bottom of the ratio, and the top part is how many fit the description we were asking for, which was, given that we get a black marble, what's the chances we came from jar B? Well, this black marble was from C, this one was from A. This is the only instance where you have a black marble and you came from jar B. So out of that 6/12, just 1/12 of the time did we come from jar B. And so our ratio to determine the probability is 1/12 out of the total 6/12 that ended in a black marble. And if you reduce that down, the 12s are going to cancel out and you just get 1/6 for your final answer. So that's your answer for part A. For B, what's the chances the ball is white given that it is drawn from jar C? So don't overthink this one. If you know you drew from jar C, what's the chances you get a white marble? 1/3. Because 2/3, there's 2 black marbles and there's 1 white marble in jar C. So the chances it's white if you drew from jar C is 1/3. And then C, what's the probability that the ball is drawn from jar A given that it is white? So let's look at all the branches that end in white. There are 3 of them. The total's up to 6/12 again. So the total number of times that we end in white and drawing a white is 6 out of 12. Which portion of those came from jar A? So it's going to be one of these 3 numbers that we added together to get 6/12, and it's this one. This is the part that came from jar A. So 3/12 out of the 6/12. That needs to go on top. Sorry, let me move it up there. 3/12 out of our 6/12 is our ratio we're looking for our answer. And if you reduce that down, the 12s cancel out. You have 3 out of 6, or reducing the fraction. You have a 50% probability, 1/2. If you got a white marble, there's a half chance that it came from jar A.